Okay, so let's look at a possible quiz question for tomorrow. And make sure that everybody can do it. All right? So let's see. Here we go.
Why do you keep wanting to drink it? Yeah.
All right, so let's look at this, see if you're ready for this. If the tangent is 3/4, find the other 5 function values. And what do we mean by that? What do we mean by the other 5 function values?
Cosine.
Cosine, so we need sine, and we need cosine and tangent, and cosecant and secant and cotangent. Now, this one was given. One of them will always be given to you in a problem like this. So this one is 3/4, which means you automatically know what? The cotangent would be 4/3. But how are we going to find the other 4? What do? We make a triangle. And we like to make a triangle that looks like this. See how I set up a coordinate axis system? We drew a diagonal out like that. And this is the angle we're talking about right here. It's always the one at the origin. That's why we like to set our picture up that way. So we see the origin, we see our angle. Then what? Opposite is 3 and adjacent is 4. And we know that because that's what we were told. And we remember SOHCAHTOA. TOA means opposite over adjacent. So that's why the picture's labeled that way. Are you okay with that? And then what? Burke, was your hand up?
Oh, no, sorry.
Just yawning?
Yeah.
Anybody know the next step? How do I find the hypotenuse?
It's the one across.
Well, I know what the hypotenuse is, but how do I find out how long it is? The Pythagorean theorem. I use the Pythagorean theorem. So 4 squared plus 3 squared will be my hypotenuse squared. So 16 plus 9, which is 25. Oh, this one worked out nicely, so my hypotenuse is 5. Now, can I fill in the other things?
Yes.
The sine would be 3/5, good. And the cosine would be 4/5. And then we can just flip over to here and do the reciprocals, right? So this would be, and 5/4.
When you're drawing a triangle, how do you know the F goes in there?
It always goes in that middle. Because when you draw this, you're going to set up a coordinate axis system. You're going to come out from the origin, just like that. And that is always going to be the angle. It's always the one at the origin. All right, that was easy enough. Let's have you try one now. Just change the given a little bit. But the questions are all the same.
This is for it. Will you have the sine, cosine, tangent like set up like that on both sides?
Maybe not in that order, but I'll have it set up. Okay, so here we go. Let's say, this time, let's say the secant is 13/5. Now see if you can, it's a secret, I can go here, just plug that in right now, easy points. See if you can fill in the rest while I take attendance. Karen?
Yeah.
Oh, there you are? Kaylin here today?
Sketchy.
Okay, how much progress did you make here? Hopefully you filled this one in right away, did you?
Yeah.
Because you know secant and cosine are reciprocals. Now, how did you label your picture? 5 was here, and 13 was here. Did you do the Pythagorean theorem? What'd you come up with? 12. Because 5 squared plus something squared equals 13 squared. So you did the arithmetic and you got 12. Very good. Because this is angle X right here. This is a different X. Okay, so what'd you come up with for your sine? 12/13, which means your cosecant is 13/12. What'd you come up with for your tangent? 12/5, which means your cotangent is 5/12. Does anybody have a question about that? Tomorrow you will have a half-page quiz, and that's what it's going to look like. One problem. You know how to do it. You know how to do it. Now, today we've got some really, really important stuff to do. So get your note sheets out. What we are getting ready to do now, kids, is absolutely gigantic. It is not hard, but it is so important that you are able to do this. I'm looking at, on note sheet, page 32, the back side, number 3. It says evaluate without a calculator. This is where all the pieces have to come together. Now, the first thing that I'm going to suggest that you do is change this radian measure into a degree measure. Now, we did this the other day, and this is the easy kind. What do you know about pi?
3.14.
What else do you know about pi?
180.
Pi radians is the same as 180 degrees. So this is 180 divided by 6. What is that? 30. So this is really the sine of 30 degrees. So we are going to find, without a calculator, the sine of 30 degrees. So you're going to draw yourself a coordinate axis system, and you're going to draw a circle in it, just like that. Now we're going to draw inside that circle a 30-degree angle. Now this is different than what we talked about yesterday in terms of navigation. There's no east, west, north, and south here. When we draw an angle, a pure angle, not a direction, but a pure angle, 30 degrees, we always start right here. This is where I'm going to start, my 30-degree angle, and I'm going to go up. That's the positive direction. So if I go up 30 degrees, would you agree that that angle is about like that? It doesn't have to be perfect, but would you agree it's like that?
Yes.
Because if I went all the way to here, that would be 90, right? And I'm not going that far, I'm only going 30. Every time you draw a trigonometric angle, every time, you're going to start it right here, unless it's a direction. Then we use our compass that we talked about yesterday. Now, once you get your 30-degree angle drawn, I want you to drop a perpendicular to the x-axis so that you have a right triangle. Every problem that we do, we're going to be drawing a triangle. Trigonometry means triangle measurements. We're going to have triangles all over. When you draw triangles, kids, they got to be part of the butterfly bow tie. Every triangle you draw will either be this one, this one, this one, or this one. I never want to see something funky like that. Ever, ever, ever. Don't even think about it. Every triangle you draw will be a piece of the butterfly. Will be a piece of the bow tie. So there it is. Now, tell me, if that's a 30-degree angle and that's a 90-degree angle, how big would this angle up here be? Wouldn't that have to be 60? Whoa, wait a minute. That's one of my special triangles. Tell me about the sides of a 30, 60, 90 triangle. What's across from the 30? 1 is across from the 30. Root 3 is across from the 60, and 2 is across from the 90. Now the angle that you care about is always the one right here at the origin. It's your 30-degree angle in this case. So with regard to that angle right there, this would be the opposite side. Would you agree with me? This would be the adjacent side, and this, of course, is the hypotenuse. Right, now, don't forget, we want the sine. Well, what sine? Opposite over hypotenuse. So what's the sine here? 1 over 2. The answer to the question is 1/2. You didn't need a calculator. That's what your calculator would say if you typed it in, but you just found the sine of 30 degrees completely on your own. Wow. Pretty impressive. Let's try the next one. The tangent of pi over 4.
Gotta draw a circle.
Well, tell me about pi over 4. It's 180 divided by 4, which is what? 45. So we're going to, this time, we're going to draw a 45-degree angle. So here's my circle. I'm going to draw a 45-degree angle, so make sure you understand that's what a 45-degree angle would look like. Would you agree with me?
Yeah.
What do I do once I get my angle drawn? Do you remember? Drop your perpendicular, form the triangle. You form the triangle. And the triangle you form will either be sitting here, sitting here, sitting here, sitting here. Wait a minute. You got a 45 and a 90. What's this angle got to be?
45.
45. What do you know about the sides now of that triangle? Across from the 45s are 1s. And what's my hypotenuse? Or my radius here? Root 2. 1, 1, root 2. Now, we want the tangent. Now, to do tangent, we have to know opposite over adjacent. So remember, this is the angle right here, always at the origin. Always, always, always the angle at the origin. So this would be the opposite, and this would be the adjacent. Would you agree with me? So what's the answer to the question? It's 1 over 1, which is 1. I hope you're thinking, this isn't too hard, because it really isn't. It really isn't too hard.
No, it's not.
A lot of steps, a lot of things to know, but it's not that hard. Okay, next. Secant pi over 3. All right.
Slow down.
All right, here we go. Secant pi over 3. That's 60 degrees. Abby Brady, how does Brooke know that's 60 degrees? Bingo. So are you drawing your circle and drawing your angle inside that circle? That would be what, 60 degrees would look something like this? What do I do next? Make my triangle, drop that perpendicular straight down, perfect. Now at this point, you ought to be able to label the sides. What goes across from the 60? What
Root
goes
3.
across from the 60?
Root 3.
Root 3. Across from the 30 is 1, and the radius or the hypotenuse is 2. How do I do secant? It's reciprocal of cosine. And I remember that cosine, SOHCAHTOA, cosine is adjacent over hypotenuse. So secant must be hypotenuse over adjacent. So that would be 2 over 1 or 2. Now, with a partner next to you or behind you or somewhere, would you try D, the cotangent of pi over 6? And I would love to have a volunteer or a set of volunteers to come up and put it on the board for us so we can look at it. So do I have anybody who'd be willing to do that? Troy, you're always good for a volunteer. What are you doing, buddy? No, can you volunteer to come up and do this one? Of course you will.
That's what they say.
He's done already. It didn't take him very long.
Tired. Same, dude. I don't even know what it is, dude. I'm just like, I woke up at like, I mean, probably like
Okay.
8:45.
How many of you got Route 3? Does anybody have a question about how we got Route 3? This is 30 degrees, right? And actually, we probably should say we want the cotangent of 30 degrees. So we drew 30 degrees, right there it is. Labeled as triangle beautifully. Cotangent is adjacent over opposite, beautifully done. Perfect.
If I would have left it at root 3 over 1, would you have counted off?
No.
Okay.
Now I want you to get your calculators out, because some problems have to be done on the calculator. The only reason that we could do these is because the triangles were special ones. They were 30, 60, 90, or 45, 45, 90. Look at your note sheet 33, item number 4. It says we're going to type this in on our calculator. We're going to find the secant of 10 degrees. Now, the very first thing I need to caution you about is that some of the problems are in degrees, like A and F, but look at B and G. They are in radians. You have to pay attention to that. Your calculator will deal with it. Your calculator will be just fine, but you have to pay attention to it so that you can make sure your calculator is in the right mode. Press the mode button, which is right here in the top row, the second button on the calculator. And do you notice that one, if you go down, for me it's down 3, it might be down more or less than that for you, but one of the options is degrees and radians. Do you see that? You have to make sure the right one is highlighted for the problem that you're doing. So if I'm going to do problem A, I need to go to mode and make sure degrees is highlighted. So I'm doing that right now because I was in radians, so I've got degrees highlighted. Did everybody do that? Okay. Now, I paid $100 for this dumb calculator, and there is no secant button on it. So I got to get creative. What do I know about secant? It's reciprocal of cosine. So I physically type on my calculator 1 divided by cosine 10. That's what you type. There's no other way to do it. Please don't try pressing any other buttons. You will be wrong. 1 divided by cosine. That's how we put a secant into our calculator. You should have gotten as an answer to problem A 1.0154. Did you get that? Let me go through those buttons again to make sure everybody's got it. In order to put a secant into my calculator, I typed 1 divided by cosine, and then in this case it's 10 degrees. Okay, Maya?
What is that, like, over the sine and cosine buttons, it's like sine -1, what are those
We're
for?
gonna talk about those tomorrow. Those are not, they're reciprocal buttons though. They kind of look like they might be because they're actually the inverse. And we use those to do something entirely different that we'll talk about tomorrow, okay? So I'm gonna emphasize one more time, if you want a secant on your calculator, the only way to do it is 1 divided by cosine, okay? All right, now let's try B. Uh-oh, B is a plain cosine, so that's easy, but notice the angle is in radians. So I gotta go to mode and change back into radians. Make sure radians is highlighted. Okay, then I will just type cosine. Now you all have a pi button. Use it. So I typed cosine, and now I'm going to type pi divided by 9. Your pi button is over right under your clear button. Or at least mine is. Yep, just that's what it says in the problem, pi divided by 9. So we did the cosine of pi divided by 9, and for that one, you should have gotten 0.9397.
This word, does it make a difference if you close the parentheses or not?
The parentheses should actually, you mean the end parentheses? No. All right, let's look at C. Okay, guess what? What mode is problem C? Degrees. So make the change. I had a kid take a test once in all the wrong mode. Every problem's wrong. You've got to make sure you're in the right mode. So we're in degrees for problem C. We're doing problem C. Okay? Now, who remembers how to put this into our calculator? First press tangent. And then we type 28. How do I get that degree mark? Second angle. And then I type 11, and then I do second angle again.
Do you close the parentheses?
You can at the very end. Don't do anything till the very end. You actually don't have to if it's the last thing in the problem. But if you feel better closing it, go ahead. And you should have gotten 0.5358.
Yep.
0.5358.
Wait for that one. For the gradient degree.
All right, let's try another one. I don't know how much time we have left.
1 minute.
Okay, how are we going to do, what are we going to do with D, folks? First thing, you're going to put your calculator into radians. How are you going to type a cosecant? 1 divided by sine, and then put in 5 pi divided by 16. 1.202 is what you should have gotten.
Is our quiz tomorrow just over this?
Your quiz tomorrow is that one, no, it's that one problem we practiced.
Oh, okay.
This board.
All right, now
So, this one was last night.
Did you quiz?
Yeah, were we supposed to like, it was like,
This should have been last night's homework.
it was like, it was.
Well,
like a
no, the,
You said
last night's homework should have been given one function, find the values of the other ones.
Oh, yeah.
That was ordered then. I'll double check.
Okay, because on the website it was like 4.2, 117.
Yeah, no, that was, that's what we did yesterday. That's correct. Tonight, this isn't what we're doing.
Because like last time I like did it,
Okay, the practice quiz we just did you understand that? That's what last night told us. That's exactly what last night told us.
Oh.
Yeah, right.
Tonight,
My cough stuff is not.